several years now by Russ Manis. Before we get to Russ, I want to introduce the president of the RFA, the Replica Fighter Association, which has been kind enough to allow us to use this space. I'll introduce Tony, president. Thank you.
Well, I don't know if I would accept kind enough. It's not kind enough. Last year, I don't know if any of you were here, they asked if they could use this and build my fuselage. So it wasn't going to be no. So I have to thank them. But the Replica Fighters Association is a group of guys like most of you, I assume, we're home builders, and our job is to support other kooks like us that are building replicas of military aircraft, do it in a safe manner. That's what we're about. And Russ and I met a couple years ago because I used to do a infusion for him, but it was just single bag infusion. He had a double bag infusion, and I saw it, and it solved a lot of problems I was having with building my airplane and my parts. So we became friends in about 10 seconds, and we've been very good friends ever since. But I'd like to thank Inegra for having him and for doing this here and supporting the RFA. So without further ado, here's Russ Manis.
Usually I talk too low, so there's this thing on my head so you can hear me this year. Thank you for coming. It's a real pleasure to be here this year. Got a tremendous program set up. We're going to do, as you can see, two different aircraft fuselages. One is the Starlight, which you can see down here. It was originally designed in the 80s by Mr. Mark Brown. Brian now owns the rights and all the tools to the aircraft, and he was kind enough to allow us to use his molds for this demonstration. What you're going to see today is on that one will be a fiberglass, a carbon Inegra, a core, and two carbon, and then we'll infuse those parts with a resin system from Scott Botter, and they'll be talking to you later in the day on that resin system, what it's about. Then we're going to move on to this project, and we're really excited about it. This is what we're building over here. If you guys were not aware of what we were actually building, nice renderings. Kind of a pretty little airplane, single seat, something to go have some fun in. I'll look at these later on, but please feel free. So over here, we're going to be doing an epoxy infusion on this side. So on this side here, again, we will have glass, and then we will have carbon Inegra spread toe, light texture, and then we will have core, and then we will have an additional 2 plies of carbon. So on one of these molds, and I haven't decided which one yet, I will do a double bag infusion. The benefits of the double bag infusion are really tremendous. As we get into that, I'll explain more in detail how that works, why it works, what you can accomplish with it, and when not to use it. So I want to introduce the guys that are helping us today. Everybody, you guys get ready to raise your hands so everybody can see who you are. Tom Mann. He's a home builder and friend, and he was gracious enough to give us some time this year to do this. Tom, he's got a composite shop. He's been involved in composites basically his whole life, like myself, so very happy to have him here to help us today. Jeff Starcher, he is with Scott Botter, the resin company. And they were gracious enough to provide all the resin for that aircraft demonstration today. Jeff, where's the other Jeff? Oh, Jeff Glazier. I'm sorry, Jim. Jim Glazier. He's with TechStream, and TechStream was gracious enough to provide 2 different, very specific materials for us. One of them is a spread toe carbon, and the other is a spread toe carbon Inegra blend. Both of these aircraft will have Inegra in them. The Inegra is there to provide a little more ductility on the exterior of the aircraft so that we can mitigate damage tolerance. We can up that significantly. Lassie. Lassie's a technical advisor for Scott Biter. He too is given his time today to help us with this program. Dean Bugner. Where's Dean? He's on the ice run. Jen Hanna. She's everything I'm not. I mean, she keeps me in line day to day. It's great. Cassie. Where's Cassie? There she is back there taking pictures. She's our media person. So if you need any additional information, you can get with her. Jim Glazer's son, Max, he's been here a couple of years to help, and it's always fun to see the young guys coming in and getting their hands dirty and helping us put this program together. Brian, I already introduced you. Jimmy Carter. Jimmy Carter is a longtime friend. We've known each other for, 20 years. Jimmy's got one of two G102s. G10, yeah, 802, which is like this on my hat. And super neat airplane, little pusher. It was done in France, and really neat deal. Who have I forgotten here? I think I've got everybody. Oh, and Lori. Lori is with TechStream, and she's here to answer technical questions and technical support type things with the TechStream material that you guys will see. As we go through this, we'll start showing different materials. If you don't have the full schedule, I want you to know that we've got it all listed on the back of the palm cards, what the schedule is for each day. All right. Is there any questions before we get started? Everybody's good? And, okay, guys. Oh, Jeff Curlow. I am so sorry. Jeff Curlow is the one that actually designed this little canard aircraft, and he's responsible for a couple of other really exciting airplanes. He had his large version of this, which was a sixth place here a few years back. Beautiful airplane, flew well, gorgeous. He's had this kind of on the design board for 20 years, and I saw it for the first time about 3 years ago. I said, Jeff, we really got to do something with that. And so we talked about it, we played with it, and here it is. So what you'll see us start doing today is, like I said, we're gonna do the layups today, and we will probably start some of the plumbing for the infusion and for the vacuum lines, and we'll do some vacuum bagging. We won't seal anything up today. That'll be tomorrow. So we're going to get after it.
Alrighty. As they get started, what we're going to do is we're going to go through some of the sponsors to talk about their materials, just to give you a little bit of education on the different materials that are being used. Before we do that, I want to go through the sponsors. You hit on some of them. Some of them are not here, but it took a lot of people to make this happen. Time, money, effort. So we want to make sure that we give credit where credit's due. We already mentioned Tony and the Replica Fighter Association for using the space. We've got Composite One. Composite One is a distributor. They offer anything from fabrics to supplies to resins, anything to make it happen. And they were kind enough to donate a lot of the supplies that we'll be using. Composite World magazine. They've done a lot of media on Oshkosh. They did a story from last year. They did some spotlights leading up to this event as well. Their magazine is on the corner here. It's a great magazine if you want to learn more about composites, or you love composites and you want to keep up with the latest innovations. So we've got plenty of those. Texonic. Texonic supplied several different fabrics. I'm not sure exactly which ones. I can get that from Russ if you guys are interested. But Texonic is a great partner of Inegro, and I'll talk more about Inegro. But Texonic makes fabrics from basalt, Kevlar, other aramids, glass, carbon. They are really a very technical weaver. They're located in Canada, also have some weaving capability in the US as well. Extremely, extremely brilliant when it comes to designing fabrics that have function. Team Textiles, that's another weaver that has supplied fabrics. Same thing, extremely talented at designing fabrics that have a purpose for what you want to accomplish. They're located in Rhode Island. We have TechStream, we already mentioned TechStream, and we have some of them on hand here to help us. It's a very innovative spread toe carbon, has a really cool look if you have not seen it. If you were here last year during our demo, that was what we used for the fuselage. I don't know that we have any pictures on hand, but we have plenty online, and Composite World has also published some of those as well. But it's a really attractive looking fabric. You'll see it today, if they get to it today. You'll see it as they're laying up some of the canard over here. Hawkeye Industries, they provided a primer surface coat that Russ likes to use, so he'll talk about that as well. We talked about Scott Bader resins, and Jeff will talk about that a little bit later. CPD is another resin company. They provided endurance resin. They'll be here at some point this week. I'm not sure which days. German Advanced Composites. I believe that's some of the, you know what that is, Jeff? Some of the German Advanced Composites. The MTI-2. The MTI-2, which Russ swears by, and he'll speak about that a little bit later. If you happen to be at his presentation yesterday at the forums, he did speak about the MTI hose, but he will hit on that a little bit more today. Raptor provided the CNC time to create these molds, and that was very, very generous of them, if you know anything about CNC. And then you've got Inegra, and Inegra is, we've got several of our team here. Russ is the chief composite engineer at Inegra. I'm in business development. Jess is marketing, and then Dean is our assistant guru to Russ, also known as our CFO. So we give him a hard time all the time. When he's here, we'll give him a hard time, but he's not here yet. So that wraps up the sponsors. Give you an idea of what the plan is for this week. Russ mentioned we have the palm cards up here. We have the schedule today. This first session, 10 to 12. They'll get through as much as they can. Doing it right, taking their time, making sure that things are right, laying up these fabrics. So 10 to 2, we'll have some time for question and answer as well. And then we're going to take a little lunch break. We're going to come back to 2 to 4, and we'll pick up from where we left off and continue the process. Tomorrow we'll come back 10 to 12, pick up from where we left off, and then again lunch break 2 to 4. We'll repeat the same thing on Thursday, and then Friday, about 10:30, we'll reveal what we've made. So we'll pop, I don't know that we'll pop them all out of the molds, but we'll pop some out of the molds so that you can see them. I don't know that there will be any drum roll, but maybe we can get some drums prior to that. So that is the plan for this week, and we appreciate you all joining us. This is certainly not something that happens every day, especially to infuse or build these types of parts outside. We know that some of the weather is a little bit unpredictable this week, but we will do our best to make sure that we put on a good show and that educate you all and get some good information. And hopefully by the time you leave here, you'll be able to do this, right? Everybody can go home in their garage and make a few planes. Sounds like a good idea, doesn't it? During this week, we also have these boxes up here. Let me make sure I say the right thing on these. So we're naming the plane drawing. If you have an idea to name the planes, they both just the canard. This one over here, which are this plane here. So if you can come up with a great name and they decide to pick that name,
you would receive a model airplane size of the canard plane.
There you go. Get a desktop model. And then what's this one, Jess?
Just registration. So you can put your information in there, and we're going to be doing drawings for t-shirts and different things like that.
Okay. Got it. You ready? All right. Turn it over to Russ.
bit about the Anegra fiber. I really love how Anegra changes what I can do with the laminate schedule. In some instances, I can build some thickness. In a lot of instances, I use it for increased ductility of a laminate stack. Most recently, some anti-ballistic pieces and a FEMA-tested tornado shield for flying debris. We were able to take a laminate stack of basically 4 plies of glass and 4 plies of Anegra together and stop the 2x4s flying at 100 miles, 130 miles an hour with 0 damage to the strike face of the part. So it allows for the part to really move, so we can increase the duration of impact, which is the period from point of impact to max deflection and back out. By doing that and balancing the resin system with the fiber as closely as we can prevent catastrophic failure by resin shearing the glass or the carbon. So when the resin fails first, it actually acts as little knives and starts cutting the fibers, which creates that catastrophic failure that you typically see. So when you use Anegra with the product, because of its elastomeric nature, if the resin is balanced with a much longer duration components, the structural fibers with a couple of challenges in using the fiber. It's hydrophobic, so hydrophobic means that it won't absorb anything. The moisture, it's impervious to chemicals. Great place to use it would be like a fuel cell, for example. Up the burst strength and protect the rest of the laminates. It's just impervious to anything. But because it's hydrophobic, we have to encapsulate it with a resin, not wet it out. It works very differently. So if we weren't using Anegra in these 2 layups, we would not have the glass that you see us putting down now. The reason the glass is there is for no other purpose for me to control the encapsulation of the Anegra fiber that's going to be used close to the surface. It's also going to allow me to abrade that surface for primer later without getting into the Anegra and damaging those fibers. So I'll try to protect the critical laminate stack from any abrading in the future. So when you're doing things what's the thickness of the laminate going to be? This right here is a plain weave scoured 4-ounce fabric. Okay, I like to use woven bale, but I have a ton of that, so I'm trying to use it up. But typically I'll use like 1.5 ounces or a 3/4 ounce woven bale. Okay, which looks like silk almost. Just enough to give me a nice encapsulation of the Anegra fiber. The laminate thickness, a little hesitant to pass these around because they haven't been trimmed and they're very, very sharp. Okay. I mean, it weighs. a proper resin infusion, that's what you can expect to have for the surface of your parts. Or if it's a part that you don't have a mold for, but you need to get it wet out, you can actually infuse it by itself by building a bag around the part once you've got it laid up, and heating resin and flowing through that. And you peel apply it, which takes all your excess resin off and gives you a really nice, dry, good surface to secondary bond to. So the laminates on this one right here, this is 100% carbon on the face, and then it is a ply of this, which is carbon and agra. So I'm sorry, it'll be glass, this, then the core, which is this has got a 1/4 inch PVC chrome core. The cores are scored and scrimmed, and then they are perfed every 2.5 inches. So when the resin flows across the back side or the top side, not only am I flowing through the little channels to feed properly, but I've got little holes every 2.5 inches in the core, which allows the resin to go down, and every 2.5 inches gives you about 1.25 inches, 1.75 inches square to wet out with each of those single holes. The perfectly wet out face such as that. So in terms of laminate thickness, that's 1 mil. This is 1 mil. This is 1.3 mil. All right. So on the back side of the core, this first, then a layer. Have one more ply of this 4.7 ounce carbon fiber, which is this on the back side. The back side thickness is going. That's all that's required for the structural requirements of these two aircraft. Now there will be some isolated areas where we do isolated reinforcement, stuff like that. But by and large, that is the extent of what you're going to see built today. If I pass this around, you guys promise not to cut each other with it.
It's 1.5 mil on each face.
No, sir. It's 1.3, 1.5, and that's because of the plane weave.
Russ,
Yes.
you want to talk about the spray adhesive, the 3M that they're using to protect
Yeah.
the powder pin?
Okay.
Hey, Russ?
Yes.
Another question, Dan.
Yes, sir.
What rates does it
Russ, I'll touch on that in a minute.
Okay. We're using some tackifier here to help hold the fabrics in place into the tool. For the purposes of this demonstration and the resin systems I'm using, we're using just a 3M Super 77 spray tack. You want to be sparing with it and only use what's necessary to keep your fabric where you want it to be. Because anything that you add to a laminate stack is FOD, foreign object debris, and you want to try to minimize that. On the resin system that we're using on these two parts over here, the Super 77 will 100% become part of the resin system. It'll attack it and melt it, and it'll flow with the resin, and it'll be there. On this one, because it's an epoxy, it won't 100% become part of the resin system. So they'll be as sparing as they can there just to keep things in place. They're just a mist, and it'll hold it all together. A lot of times, if I'm doing something that's drapes into a mold, or a lot of draping, a lot of times won't even use any spray adhesive. I'll actually just use a masking tape along the edges to hold it up. And the vacuum typically drives everything into the form of the shape that you're looking for. How many of you guys have built vacuum bags? Quite a few. Do you all want to learn to build vacuum bags? We're definitely going to build some vacuum bags. And whether you do the infusion or a wet layup, you're always going to get a better part with a vacuum bag. And some of the differences are insignificant but really important. on a wet layup vacuum bag part, you usually will run your laminates, and then you'll run a peel ply, and then you'll run a breather, a bleeder, and then a breather, and then a bag. Well, with an infusion, you waste resin by doing it. So with infusion, bleeder and the breather off. The addition of a flow media is used with infusion so you can evenly resin to the part, and then that in the bag will all be peeled from the part and thrown away once the part is finished.
Can't really see what's going on in the process.
What they're doing is that's the spray pack. That's the spray pack. Yes. Yes. Okay. All right. And actually, I laid this up wrong. I'm sorry. It has no effect on the spread toe fiber. This is a 12K fiber. So a fairly large toe of, well, they have to use a binder to hold that. And so what you're seeing on there separating. That's what that is. So
Do you have any clone samples of this?
TechStream has got some samples they could probably give you, little small ones. I'm gonna pass that on back. Any other questions right now?
You were applying, it looked like a 2-ply tape or something around the perimeter of the
Okay.
is that just
All right. That is to molded that joggle into the part we out. So this is a specifically sized tooling wax I-temp so that it's not affected by the exotherm of the resin system, and it'll create a very nice clean joggle for us. So when we put the two parts together, that joggle gives us a very nice bonding area. There you go. Yes, sir. Yeah, and if you guys would like to see that. There you go, sir. Sir?
And Rick is the supplier of that and the documentation. That's essentially the thickness of the supplier of that tape and the documentation. That
No.
wax.
Yeah, yeah. Okay, McMaster Car or Composite One. Okay, Composite One's one of our sponsors for this program, so if we can buy something from those guys, it helps us do this again next year.
Yeah.
You know, so yes, sir.
What I said.
It has an come out with the part and we'll just take that out. Yeah, it's going to make an indentation, and that indentation creates the joggle for me to bond the two halves together and pull that up with fiber. It's a butt joint. There's a back plate that it's bonded to inside, so it's bonded to a back plate. They're butt jointed. Then I have a joggle in the skins, and in that joggle I will put a carbon fiber tape, 2 plies of carbon fiber tape all the way around, so that I make up the thickness of the sheet guys. Now I have an inner and outer bond.
It'll also be easier to
the back. Any questions? And you guys can stand up and look at what they're doing. But they're having to work that bandit to try not to have any kinks or any wrinkles, and to try to minimize cutting the fabric.
Yeah, if you can avoid it, that's good. Sometimes you just can't.
And that's all fine. That'll flatten out.
I talked to him 3 years ago.
Fix that for me. came in. Yeah, so today we will have we'll have all the skins and the cores laid up by the end of the day. So you can see it's a job. That's correct. Yeah, we'll a very light amplifier. Yeah, and we'll even do it when we put the core down. When we put the core down, we'll kind of hold it from shifting and moving. Super 77. I like to use AirTech AirTap 2 with epoxy, but it didn't show up. It didn't get here, so I'm going to use what's here. It's not going to hurt my part. It just won't make as pretty of a surface. Okay. So now, I don't know if she told you or not, but this is Composite World Magazine, and it's a free magazine. You don't pay for these. You just subscribe, and they'll send the magazines to you. If you're interested in composites and what's going on in the world, these guys cover what happens globally. So some really neat new fabrics, new fibers, new processes, all that type of stuff is in here, and it's a good read. Like here is on the 787, and some of the stuff early on that. So everybody's interested in what we're doing there. But these people have been more than kind to me through the years. I've been written about in Composite World Magazine over the last 12 years, probably 15 times, for various new concepts or new processes or projects that I'm involved with or associated with. So a lot of times you can pick one of these up and see what I've done lately, what's Russ done lately. But I would highly recommend you guys subscribe to this. Grab one and take it home with you. We have tons of them. This program will be in the next month.
15 miles off
You'll
of
be able to have that.
Memphis International Airport. All the FedEx traffic turns right over.
What they're going to do over here is they're going to do a complete, one complete skin, and then they'll add additional plies to fill out the straights of the plane. If this laminate was going to be plied together or stripped together within the fuselage, the plies would have to be laid down from the front of the aircraft to the rear of the aircraft, always. That keeps your laps with the wind all of the time. Even though you have your structure done and it's wet with resin, the rule is that you always keep the fly drops with the wind. So you approach the front, keep fly drop, and fly drop, and fly drop. If you're doing fly drop, which is just several different flies placed in there, not only do you always go with the wind, but you always never do less than a half of an inch overlap. Never. I like to go with an inch. Drops around within the, so you don't wind up with one, a big hump where the fly. That goes grab that.
Aaron, and I'm with TechStream. And TechStream is it's a carbon fabric made by taking the toes, as Russ explained, and then we spread those toes into a very thin tape, and then weave those tapes into a fabric. And so the resulting fabric is you get a much thinner, stronger fabric because you don't introduce fiber crimp into the carbon fibers than you do in a typical fabric going up and over the toes. The fiber crimp that's introduced in the traditional fabric reduces the strength because you're breaking the carbon fibers with those up and down undulations. So in our fabric, we spread those toes into a very thin tape and then weave those tapes into a very thin fabric, mostly eliminating any of the fiber crimp that happens in a traditional fabric. Yes?
Yeah, what's the price comparison to the net compared to regular weave?
So in terms of TechStream, you can't look at it that way because TechStream, in some cases, you're going to use less plies of TechStream than you would a traditional material. So, you know, we don't really throw out pricing in terms of that, but basically, you have to look at the whole process with TechStream. You have to look at what else are you eliminating in the process. But the idea is that it's used where you need thinner, lighter weight, but the same kind of strength that you would in a traditional fabric. Yeah, it's the fabric he was showing you, but so basically we're taking the same toe that they would use in a traditional fabric, but we're going to spread that into a very thin tape. So now when we weave our tapes, we don't have to go up and over that big thick. It shows you on the back of the part. You're not going up and over that big thick fiber. So you don't introduce that rinse the fiber and erase the fiber.
It's just a 4-ounce glass. It's mostly going down for finishing reasons. The texturing is
About 2 inches on this end, and that's it.
That's enough.
If you need some more.
You're good.
You got plenty down here, Jimmy.
You find the ice?
Walked everywhere. I even walked to the area that they have all.
So you'll get to see an example of how they get it over.
Jeff, come and work with him. You guys need this.
Well, let me give you some examples of where texturing is used. Maybe that'll help. One of the biggest places that are really used in all the Formula One cars. But some other areas where we're using sporting goods. So our material is used on the outside of a bell helmet. It's also used in hockey sticks, power hockey sticks. So if you can imagine, those square tubes that are making out of our material. So yes, the answer is you can form it into those types of things. Any other questions? Okay, do we have any more questions at this point? Yes, sir. And before I do that, I had a gentleman that asked about Negra fabrics and what the available weights. Sir? You asked about the fabric. Yeah. I was going to talk about that now, but you can take your picture too. Okay, great. Before we get into the single bag, double bag, which would be a rough question, we had a question about the Negra fabric. So I'm going to talk to you a little bit more about the Negra fiber.
Yeah, just a little overlap.
The Negra was created or developed between the years of 2004-2008 in Greenville, South Carolina. And this company, Negra Technologies, put the product in production in January of 2012. So it has not been on the market that long. But what it's mainly used for, number one, it's the lightest commercial fiber available. It's about half the weight of carbon.
It is not carbon, it doesn't do the work of carbon, but it's there to protect carbon. So when you have carbon carrying the structure and giving the product stiffness, the Innegra is there to protect the carbon from catastrophically failing. It gives it more durability. So I have these little coupons up here, and they're basically just a reverse. I've got carbon skins with Innegra fabric in the core, and then I have Innegra skins with carbon in the core. Innegra is a very ductile product. Carbon doesn't usually do that. So the Innegra is allowing, it's loading first, allowing the carbon just to kind of go for a ride. We take it the other way. I cannot bend this like I did with the other coupon. But we all know that when carbon fractures, it can be kind of scary. You can have catastrophic failure. Even if you get a fracture at the surface, you worry about that fracture propagating throughout the rest of the laminate and eventually exploding, something like a hockey stick that will bust apart. You've seen Formula One and Indy, when the cars have accidents, the carbon pieces and the shards go everywhere. So what Innegra does is it holds that laminate together. So if I broke this, it keeps those two pieces together. You do have a hinge break, but this is also a very fine laminate. When we do thicker laminates, and the Innegra is there to protect. Let's say the Innegra is underneath the surface layer, and there's 20 more layers of carbon down here. If that carbon on the top gets a fracture and takes an impact, the Innegra is going to keep that fracture from propagating through the rust. It dissipates the energy. So it's a very tough material, very flexible. So you have toughness, you have lightweight, impact resistance. It actually has great dielectric properties too. So if you're looking at signal transmission, it allows that signal to transfer through. And it also has damping properties. So carbon does not really dampen the feel, but the Innegra will do that. Glass doesn't do that either. When you look at the Innegra fiber, it's used in a lot of applications, let's say snowboards, surfboards, stand-up paddleboards, where you don't want to feel that tinny feel. So it helps to keep that energy from transferring up into the rider. Same with bicycles. So the question by my friend over here was, what available weights does it come in? A lot. That's the answer. You know, anything from less than 1 ounce to over 20 some ounces. There are a lot of different companies making different fabrics, even scrims, very open materials that almost look like a net that provide, some of the surfboard companies use that type of material. And then you look at some of the ballistic stuff that's up in the 20s, 20 ounces. It's being used in wind blades and automotive sporting goods. It's used in a lot of variety of different applications. It's a very interesting and versatile material. Russ has studied this material for quite some time now, and it really has a big impact depending, no pun intended, maybe pun intended, really depending on where you put it in the laminate. It can really change the performance. So we can have two different companies we're working with and put it in a different place in the laminate, and they have two different products at the end of the day, even though they're both using it. So it really depends on what you want to accomplish and where we would help you design the Innegra into that part. And he can talk about where he would put it in some of the aerospace or aircraft parts to give you kind of a better understanding. But the Innegra comes in 100% Innegra, comes in co-wovens, which, you know, carbon Innegra, basalt Innegra, aramid Innegra, glass Innegra. And then we also do a product, so that's an Innegra S. We also have a product, if you take our brochure, that is Innegra H. H means hybridized. So we take the yarn, the Innegra yarn, and commingle it with a high modulus fiber, like a carbon or basalt or glass. And we make that into basically one yarn, which is an intimate blend. The performance is, you get a little bit of thicker fabric. So instead of laying out carbon and then Innegra, now you have those combined into one laminate. You can adjust the ratio. Maybe you want 70% carbon, 30% Innegra. Maybe you want 30% Innegra, 70%, or vice versa, 70% Innegra. So we can adjust those things. So there's a lot of different things you can do with that fiber. Russ mentioned earlier, Innegra is a hydrophobic material. The commingled helps to improve the adhesion because you have the bonding points of the other fiber. You also have them working on more of the same plane as well. So there are several different products out there that you can accomplish a lot of different things with the Negra, but it is a very versatile, newer fiber on the market. We're trying to educate people and get more people to know about it because we really feel like there's a lot of benefits in many different applications. It really kind of just takes engineers to put another tool in their toolbox and figure out some neat things to do with it. With the commingled? Okay, so the question was with the commingled, is it just commingled in strength or is it twisted? It's actually needed. The process infinitely one shot. They're not twisting and they're not flat. When you look at this, which would still be considered kind of a commingled, that would be flat, but straight. So that's the way that TechStream does theirs. When we do it by the yarn, if we gave them that yarn, commingled with carbon and Negra, they wouldn't be able to do that. They would not be able to spread those two. So it gets pretty intimately blended. In fact, when you start to try and pull the two fibers apart, it'll burst nest at some point in this tangle. But you can twist them together. We haven't really found improvements in properties there that we tested over something like a co-rolled material.
Start seeing them. Start putting rock.
Kind of like a spun core. Yeah. That's interesting too. That's something we started talking about here recently. Like I said, there's so many different things that we can do, and yeah, it's actually the next 5 to 10 years will be pretty exciting at Negra. We look at different things, and more people become aware of it and start just trying different things with it and what they come up with. Obviously, our expertise is in making the yarn, but the composite industry is so innovative. You just never know what somebody's going to come up with. So we're excited for that. Any other questions on a Negra before we get to single bag, double bag? All right, I must have answered all your questions before you were able to ask them. Okay. I also want to introduce Dean, since we were talking about him when he wasn't here. Raise your hand, Dean. That's our man right there. All right, let me grab Russ, and we'll talk about the double bag, single bag. Before I turn it back over to Russ too, I want to let you know that on these here, on the one side it'll have our website, the negrotech.com website. On there is a page dedicated to ACI and this demo. The presentation he did yesterday is on there already. We'll list, once we're finished, we'll list the materials that were used on there as well, so you can have that information, but very useful information on there. It is on negrotech.com. Right when you go to the home page, if it happens to be months later, there is a ACI OSH16 is on here, and that's the way you can search it. So we'll have that information. You can also contact Russ through the website too. All right, so single bag versus double bag.
Okay. Single bag is normal processing, period. The process for double bagging was actually with Boeing and NASA back in the early 80s. The purpose of the double bagging back then was simply to control or prevent blown bags in autoclaves. If any of you are familiar with how autoclaves work, it's heat and pressure. So as you elevate the pressure inside the autoclave, you're dumping vacuum at the same time, so to keep everything kind of evenly balanced. And then you're applying whatever pressure you need for that particular part's consolidation. Well, a lot of times when you use a tacky tape in a high temperature, low elongation bag, under pressure, the bag will actually burst. And so they decided that loss of the part, and so it works very well. Working at Lockheed Martin and managing a lot of the composite processes on the midsection of the F-22 for Lockheed Martin, I started looking at what we were doing and how those blown bags were saved by the second bag, and I started to think about what is it I could do to utilize this in Infusion, and how could it benefit me. So I started playing with it, and I really wasn't getting any benefit other than just taking twice as long to build the darn bag. Well, then it dawned on me, I've got to vent the 2 bags. So I would build the first bag, and then I would put a breather on top of the first bag, and then build the second bag to the outside perimeter of the first bag. Now I can apply pressure to the first bag as though it's part of the laminate stack. Now, a lot of you probably haven't seen this, but some vinyl esters, polyesters, acrylate esters, all resin systems, some of them are highly susceptible to moisture. So if you don't have a super dry environment, you can create a lot of problems with your resin system, and they can outgas and they can oil under certain vacuum levels. Using 2 bags allows you to use differential pressure. If you want 100% consolidation of the part, but you can only pull, say, 23 inches of mercury before your resin boils, you can do it. You can actually pull your resin at 23 inches of mercury, and maintain atmospheric pressure as the pressure against the bag itself. That's the 2 differences. So if you on epoxy, then you can do the same thing. Some of the other real benefits are, if you have parts that are kind of hard for you to work because they're large and they've got deep impressions or indentations or things of that nature, you can always run an intensifier on the first bag if you want to, but you typically will pinch off your fabric before you actually move it with an intensifier under a single bag. If you put your intensifier on the back side of the first bag, you can drive it down with the second bag so that you can minimize or eliminate any bridging that you might create in the layout. But for me, the single best benefit of it all is that I can use the second bag basically as a press. So you can actually, without affecting the first part that's under vacuum, you can actually vent and reapply vacuum to that second bag all you want, and you actually can hammer that part down into space. So that's kind of the benefit there. So obviously, it costs twice as much in tacky tape and it costs an extra bag, but it's really cheap interest too, guys. If you do have if you get completely finished with your first vacuum bag and you pulled vacuum on it, but you can't seem to get a perfect vacuum seal, you've got a leak somewhere. It could be along the tacky tape, it could be just a pinhole in the bag, it could be anywhere, and it drives you insane. Or the second bag, it doubles your chances of getting 100%. Now, if you do have a pinhole in the first bag and you pull full vacuum on the second bag, obviously you're going to get full vacuum on the first bag. So don't build a second bag if you've got a leak on the first bag. You want to talk a little bit?
I was just going to say, then you have to do a third bag in order to get the results that you were talking about before.
So does that answer your questions on the double bagging? Depends on what I'm building and whether or not I'm going to do an oven cure on the part. I like using higher elongation bags. It's just my preference, but I can build a bag just as fast and just as good with a 0 elongation high temperature bag. For starting out learning how to vacuum bag or how to do an infused part, you do want to use something that's fairly elastic, just to give you the best chance of making a good bag. When we start to do the vacuum bag, we're going to talk quite a bit about the pleating and how significant that is, and how really simple it is to do a pleat in a bag super fast that doesn't leak. I have my way of doing it. I know what the Boeing spec is. So we could talk either way that we need to, but I think seeing it probably will help you understand it more than anything. Any questions?
Is Jeff still here? There he is. You ready? Yeah. So Jeff wants to talk about the Scott Vader resin. I saw him trying to hide from me over there behind the mold.
What would I rather do, talk or work on putting down fabric into a mold? So my name is Jeff Starcher. I'm with Scott Vader. We manufacture multiple types of resins, polyester resins, vinyl ester resins. The one we'll be working with today and that we did last year was a urethane acrylate. Show of hands, how many were here last year? A lot of new people, fantastic. Thank you for those coming back. Thank you for coming back. Urethane acrylates, what we do is we take a urethane, we pre-react the urethane. So those of you who've ever worked with urethanes in the past know that you have isocyanates and polyols. We take care of all that. It's already pre-reacted, so you don't have to worry about the toxic nature of a isocyanate getting into your lungs or anything like that. It's 100% reacted. There's no bad things that get into your skin. What we do is we put in groups on these so that they will cure up with standard peroxides. We'll be using one called Trigonex 239, which is cumul hydroxyl peroxide, CHP. That's going to give you about a 45-minute work time. I think we took this one out to about 60 minutes just because we didn't know what the weather was going to be like outside. So we can slow it down and we can actually speed it up just a little bit if we have to. Why are we using a urethane acrylate instead of epoxy? Everybody uses epoxies or vinyl esters. So one of the main reasons is water absorption. We are about 1/4 of magnitude better than a vinyl ester or an epoxy when it comes to water absorption, which may not be a big deal in this application. We are the elongation by the resin itself is about 3.2%, which isn't a lot, but it's really bonds extremely well for the carbon fiber into the negra. So we, in this part,
I need to grab a drink.
if you were to take a piece of it without the core in it, typically epoxy you would get maybe about that far in, and you would start to hear cracking and cleaning. This one is actually been apart, so it's not soft, it's not gummy. It does have a high particle hardness, but at the same time it does have a toughness because it bonds into the fabric very well. One of the other advantages with the gallon, this is about 8.6 pounds per gallon, and I'm not sure how many gallons we're going to use in this, but an epoxy is about 9.4 pounds per gallon. So if you put in 10 gallons, your epoxy part is going to weigh about 10 pounds more. Just a little something a little fun. I see that's here. Here's the swirl. And swirl makes silicone bags. Silicone floor bags. And the urethane acrylate, it works and plays well, very well with silicone bags. We're using a customer just south of here, a couple hours south, and they've had at least 250 pulls on a silicone bag with our resin versus epoxy where they get about 10. So it mixes with, like I said, with the standard peroxide. It smells like a vinyl ester or a polyester resin, but certainly you don't have to worry about the amines that you do with the epoxies. And because the isocyanates are pre-reacted into it, you don't have to worry about that as well. So very tough part, very lightweight part, and it's great for making airplanes work. Yes?
What's the biggest drawback?
Biggest drawback?
Why doesn't everybody use it?
Well, that's what I'm asking too. Why isn't everybody using it? That's why I'm here. I'm trying to convince everybody to start using it. Nobody really knows about it.
So what about material properties?
What kind of properties are you looking for? Okay.
So I understand the fiber carries most of the load.
Right.
Some material properties,
We have all that.
how does that compare to saying
We are equivalent to epoxies in some areas, worse than a little bit in other areas. It just, there's 100 properties we can look at. tensile strength, we're equivalent to 3-point bending. We're just about equivalent to. We do better in UV. We do better in moisture absorption. We do worse in. I think which ones we do worse in.
How about
Peel strength is always the hardest part for any resin to go through because it's not made to peel just like an adhesive. But it's equivalent to a vinyl ester, maybe about 92% of what an epoxy would do. Shrinkage, you definitely have shrinkage. That's the difference between epoxies. Epoxies, you will get shrink, but with these resins, you will get more shrink because you have styrene inside, and the styrene has to go someplace. It's used in the crosslink. So you're going to get about 4.5 to 5% shrink with these resins, which helps when you go to demold as well, though. So this particular resin, I will say this: it will stick. It's designed to stick to fiber. It's designed to stick to everything. So if you do not have your mold surfaces waxed properly, you're in for a fight.
How about viscosity?
Viscosities for this resin right now we're at 200. This is about 200 to 250 centipoise. Epoxies are typically the base resin for an epoxy will be around 1600 centipoise, and then when you put your amine into that, depending on what amine you use, you're probably going to be around 1000 centipoise. So this is going to be a much thinner product. Great for infusion. It was designed for infusion in mind. We've done large boat hulls with it. We did an airplane last year. It belonged to Tony. Those of you who were here and saw it demold, it came out really nice. It was a beautiful part. So we've had great luck with it.
How about thermal and curing properties? Like what kind of temperatures can you use again, and how long does it take to cure?
Right. It's going to cure up overnight, 24 hours at room temp. You will get about 95% cure out of it. What we typically tell people is if you want to get a very glossy surface in an application like this, when you're done infusing it, let it gel up. It's going to gel up in about 45 minutes to an hour. After it gels, take it outside and set it in the sun. That will help thermal cure. Most people, you guys are home builders, you don't have big ovens at your house where you can move this thing into. But if you do that, you'll get a really nice, shiny, glossy surface on the top of it. And that way all your shrinkage does occur inside the mold as well. So that's what we recommend this week. Very tough. That's a good question. I can't answer my competitors. This stuff is about $3 a pound. So I don't know where the cost is in that. And then specific gravity is much less. Yeah. That's right. Per pound, we may be a little bit higher, but per gallon we should be about the same. Yeah. And that's what you guys are always worried about, is how much volume you do. I'll be here the rest of the week, so
Once you get through the second, these are challenging. They are very challenging. There's always something. It's like it's just fear.
So which floor do we recommend?
I don't know.
Right. We've used balsa floors. I wouldn't use it there. PVC floor. I've used urethane foam floor.
Will your material cavitate
Yeah, I would think so. I mean, yeah, styrene will dissolve styrofoam. Yeah. This is about 42% styrene in here. So there's a large amount of styrene in the system. Yes. Post-cure is not needed, but what we recommend is, again, if you're going to cure this at room temp, right, just set it up. Just Or just leave it in the mold for an extra day or two. That way you make sure you're getting 99% pure. What you don't want to do is pull it from the mold too soon and have it sit outside and shrink. Because if it shrinks outside the mold, you get burnished.
I think we need to touch on the sprinkling of the resin. Talk a little bit about that, what they can expect, what they can look for.
It's not like it's right in front of the schools.
Exotherm, peak exotherm, Delta Peak promotion, what we can do for this time, what you use, what our gel time feels like. Give them the information in there.
Okay. So to answer Russ's questions, basically you've got about a 45-minute gel time with this resin. The way it's set up today would be about 60 minutes. This urethane acrylate cures a little bit differently than other resins do. What you're going to do is you're going to see like a plateau. So it's going to gel, and it's going to, when you touch it, it's at the gel point. If you were just to take a slug of it, you're at 100 grams of it. When you go to touch it, it's going to feel like, it's going to go like jelly, and then it'll get somewhat soft. And you think, okay, that's not cured. No, it's not. It goes to a 2-phase cure. When it goes to that second phase, it'll start getting very hot. The exotherm that we've measured usually is about 375 degrees Fahrenheit. So you're going to see a nice hot material. That's why I say you really don't need a post-cure. But any type of cure that you do, the glass transition and stuff is about 110 degrees centigrade, which is about 225 F. So it's going to get up to like 370 F post-cure all on its own. So it's going to be above its TG. So any post-cure that you do after that really shouldn't have a lot of effect, but we find it gives a nice glossy surface. And then that way, in case you do take the rag out immediately and set it out in the sun, you can say put it back inside, real quick into the dye, or into the mold, and let it sit there overnight, just in case there is any shrinkage that goes on. That's it. I have a couple questions. So the question was, epoxies are pretty ratio sensitive. This resin is ratio sensitive as well. Let me expand on that just a little bit. Epoxies, not only are they ratio sensitive, but they're also amine sensitive. You can get different properties. What's cool about epoxies, and I was an epoxy chemist for 10 years, is you can use different amines for the same epoxy and get totally different results. You get better moisture absorption, you get better infusion. Whatever the properties were you were looking for, you could change out the amine and get that. With these resins, these urethane acrylates, the resin is pretty much, all we're trying to do is get it to cure. So we're using, like I say, chemo hydroxyl peroxide, CHP. Every comp 1 has a trigonous 229. The ratio is 2% is what we say. Is it sensitive to that? Not really. You can go 1.5 to 2.5, and it's still going to be the same properties. The gel time may change by about 3 minutes either way, but this is a pretty unique material in the fact that it is not really that sensitive to the ratio. You just got to get enough of the catalyst in there to get to take over. That's the biggest thing. Once it goes on its own, it'll take off. At what point do we take the bag off after? Yeah, we say after it's cured. So, why take the chance? I know it 5-star was the first time I did this. We were in a car company that built race cars, and they put the valve down.
Your commode's a hole in the ground though.
Yeah, this thing we lost back then, and the parts fell off. Because it had gel. They infused it, they put it inside the oven, and the vacuum line came on, and the parts popped up. They just want to make sure it's a little through gel. Definitely through gel. But what I would recommend is at least the minimum of 2 hours. That's the best case scenario. So the question is, how do you do secondary bonding to epoxy parts? I would recommend every epoxy, like I said, it's different. I don't know what amine we're using. Amines will give you a blush on the surface. It makes it very difficult for other products to stick to. Epoxies usually don't have a problem. Some other products do, so I would check it. I would make just a small black and test it. Make that part put some good and see if it bonds well too. So I can't make a recommendation about the system. Yeah, but what's the mean? So diving, driving, there's only 100 of them, so when we have to test it, it's like a lot. That's what we would do is we make up a panel, 4x6 panel or whatever, and we would bind some parts to this resin and see how well it sticks. Sorry, that's probably not the best answer you wanted, but that's the truth. That's all I can tell you. Okay. Any other questions? Thank you guys for coming today. Greatly appreciate it. Yeah, it would be nice. If you think of anything else, yeah. You buy Composite one. Go to distributor. Depends where you're at. If you know your distributor's name, just call them up and tell them you want some Crest 1250.
Well, they have other resin systems as well. And they were very gracious this year in providing us the cooling system, which we built our old because it was not aircraft. And so I think it's important to kind of explain how that system works, because it's an extremely stiff mold that doesn't use. Typically, I would like to have a copy type to it. We were off at this resin system, and he assured me that I should be very fast and get it in and satisfied our achieve all of the goals that I have set forth. So, I'll talk a little bit about how the system works.
So at Scott Potter, first of all, we've been in business since 1935. We are a privately owned company. We're owned by a charity, so we can never be bought or sold. We're located out of the UK is where the headquarters is. And it's common ownership, so the employees all have one stake in it, but we don't compete that one. So they are constantly looking at how do we improve the composites business. They're not worried about so much about the composites, but they do look at some of the shortfalls in the industry. One of the big shortfalls has been tooling. The tooling market has not really changed a whole lot. Companies have come out with new tooling materials, and we decided to jump on that market very early. So what we have on this product right, or this part right here behind us is we have a 3-part system. We have a gel coat, that's the black that you see right here. So what we did was we sprayed black tooling gel coat, and it's a very tough system. So it won't crack, it won't break, it's very tight. Then behind that, we're applying this skin coat behind it. So one layer of basically resin behind it. And that is all done in Composite. So we have 3 passes of 10 mils thick gel coat that goes down first. In between each layer, you go to that just slightly. Put your second layer behind it, let it tack. Put your third layer down, let it tack. And you come behind that with your skin coat, your biluster, we call PE679. What's unique about that is it really stops a lot of printing as well. So you don't get a lot of deformation on your mold surface. It's really important. And these guys spend hundreds of hours sometimes making molds. And then underneath, we have what we call rapid tooling. A lot of tools have taken days or weeks to make because they want you to put down small layers at a time, but you have to cure, doing some kind of abrasion, repeat. Do another layer, abrade, cure. This is what we call RTR, which is rapid filling resin. So it's a 50% filled resin. It's proprietary. I'm not sure exactly what it is. But you can fill this whole layer up all in one day. This tool could be made in 1 day. So 50% filled, it gives an incredibly stiff part, equivalent to that of epoxy. But it's much cheaper. to get the carry records. So we've started launching that in March or April of this year. And you guys are the first airplane, you're the only airplane show I ever did. We do a lot in Marine, and the Marine people seem to love it. So it's really starting to take off. So we've done kayaks, four-wheel jets. We've been to the race car people, so a lot of people look at this stuff and really excited about how fast they can make it through with it. And when Russ came to me and said, "Hey, you guys have any extra tooling?" we said, "Yeah, we do." So he was excited to test it, and we were excited to go down to Atlanta and work with Russ and Jeff Curlow and make sure everything worked out well. Yes, there is fiber in there. Yeah.
No, go ahead.
It's in the resin.
Well, yeah, but
the resin goes down, and then we went out the fiber. So.
No, it's not top. We had a team actually designed specifically for us. I designed it primarily to be Infusion film. If you look at the fabric, you can't see through it. You turn it on, you can see right. So what it allows you to do is it allows you to work with So he's got several of these very unique types fabrics. Yes, sir. This one was hand laid 1 ply at a time. This one was a hinge. We wanted to try both of the systems. Of the two systems, I prefer the one that was hand laid on film. It was very nice. Notice the thickness is at least a third less than what I think that's the history. So not only was I able to maintain a very cool tool surface throughout the way up, I was able to add bulk to it without adding the expensive part, the fiber. So by virtue of the thickness, I picked up the stiffness that I needed. 5 slides of a 12-ounce fabric. So, no, that's what I was saying about the fabric that was designed. Yeah, so if you look at it head on, you can't see through it. Put it on there, you've got nothing. By the way, Team Textiles also gives quite a bit of the leg rest and a wide variety of different architectures and percentages of fiber. So it's kind of neat to see what you can do with for tooling, I just use glass. Unless we're doing a box here, in this case, towels and others.
Any other questions? I will turn this back over to Jen. Thank you, everybody.
I think some of you have just joined us or seen some people coming and going. All right, Russ is going to allow everybody to come in, come around the tool and look at what the work that they have done. We just ask that you please don't touch the tool or the fabric. You can lean over it, just make sure nothing falls into it, please. So what we'll do is we'll come over here by the 2 chairs and we'll just kind of single file around and then back out by the other 2 chairs. Please watch your step as you come over the caution tape. If you guys can come this way, and we'll just it's okay.
this kind of stuff, disturbing the fibers, that doesn't
That has no effect.
cause you any concern.
As a matter of fact, on this, as I mentioned earlier, I'm using the glass as an encapsulator, if you will, for the enagler, just to ensure that I've got plenty of resin around the enagler fiber. Secondarily is, this is a sacrificial block. So because we wanted to show you the finished part and the fibers when the part came out of the mold, we chose not to put it in the mold, so So we're going to have to abrade this part and then prime it. So this surface here will be what will be abraded to accept the primer, not the structural components that we're actually put down in.
When you put that enagler in, then you would try and be more durable.
Oh, absolutely. Absolutely. And this will all go translucent. Once it wets out, you'll see right through it. You'll see a rich black and white color, or the black carbon color. So it is sacrificial. You can see.
What is this material?
This is a 4-ounce e-glass. I wouldn't use e-glass on structural components other than, an abrasion surface. By the time we're done abrading it to prep it for primer, we will probably remove at least 50% of that fiber, if not 75%. But we will not touch the structural fibers at all. So if it was a typical part, it would have an epoxy primer sprayed into it. I'd leave the glass completely out of it, and then go straight in with the carbon and the enagler and the cores, and that would be finished. Some of you guys have worked on RVs and other canard type aircraft that are scratch built, and it's foam cores and fiberglass typically, and you guys have probably spent hundreds and hundreds of hours working the fiberglass, trying to get the surfaces smooth, get the pinholes out, go back and refill them, then go back and block it, and then fill the holes you created. And it's just a compounding, very frustrating thing. So Infusion allows you to create parts, even standalone, like a wing for a very easy or a long reason. You could actually infuse that skin and use the bag as the mold surface. And as long as you keep that bag nice and taut and smooth, once it's infused, even using low pressure, you come back with soapy water on the back side of that bag and squeegee that so that you really get a really silky smooth finish across the part. So a hand laid out part can then become less work in trying to get it finished prep for the primer.
Now the spray that you're using on this to contact the fiberglass in the mold, how much contamination is that against the system?
It's going to be, on this one, it'll probably wind up being about 2% of the total viscous material consumed within the part.
So I mean, does that resin eat into that?
The amine and the hardener will eat that, but it won't 100% dissolve it. I'll get about a 98% attack. On the Scott Potter resin systems, we'll get 100% meltdown. So that spray adhesive will actually go completely away and become part of the resin system.
You're talking about two different resin systems.
That's right.
So
Epoxy and the Scott Potter.
Which is the one that gentleman was talking about.
That's correct. That's correct. Now, I like the Scott Potter resin because it builds some phenomenally high properties, physical properties. It's not quite as good as epoxy, but it's damn close. Damn close. And in terms of cost, it's substantially less money. I just come from a world where everything we do is always been for advanced. So I stay with what I'm really comfortable with. But when I go to work with other customers throughout North America, I work out how to make their resin system work with our everybody's got their own comfort zone.
The high exotherm and the styrenes that are in it, I mean, what are the chances of that getting into the
on these, there's no styrene that would
Not
be
in
enough
the
of
epoxy.
it. And those parts over there, it is a concern. It is a concern, but the resin's only going to lay on top of that part on that mold for about an hour and a half before it gels. And because I'm not going to have any mass, there'll be no resin mass, I won't have any exotherm to deal with. I mean, it's going to be so low that...
So it's not going to go to that 300.
Oh, no. And when they talk...
Why did he mention?
Well, because that's part of what you have to look at when you purchase a resin system. On the data sheets of all resin systems globally, they're going to have all types of information. But what you're looking for is the viscosity of it, its physical properties, its peak exotherm, and gel to peak. Okay, so the gel to peak is whenever it gels, it gets to the highest exotherm and comes back down. It's gel to peak. Those are the things you're looking for. Within the context of the text of your data sheet, it's also going to tell you what your working pot life looks like. Everybody in the world uses 100 gram mass. Small pucks, 100 gram mass. At 77 degrees to determine what the actual gel time is for that resin system. So if you buy a resin system, no matter what it is, epoxy, vinyl ester, doesn't matter what it is, whatever that 100 gram mass gives you is a number at 77 degrees. So if you're at home and you're trying to do a part, and it's hot like today, you need to do your own gel time test to understand how much time you actually have to work with that specific resin system. It may say 45 minutes at 100 gram mass at 77, but on a day like today, you might really be looking at 20 minutes. So it's really important to do that.
So technically, you're not going to what temperature?
I think it'll probably see somewhere around 120, 150 range. I don't think we'll get any more than that. Now, if we put it out in the sun, it would go well beyond that. But if you do that, if you put it in the sun, you over-accelerate it, and you cause it to shrink very rapidly and inconsistently. So, some parts you look at that come out of the mold, and the mold is perfect, but the part was kind of wavy. It could have been improperly mixed resins, batch to batch to batch, so you got different exotherm rates and different shrink rates. And if you use continuous fibers like this, if it shrinks a little bit down here, it's going to affect something up there. That fiber runs the full length, and that can cause rippling and waves and distortion. Any other questions? Hi guys.
Under that same line, wouldn't you want to then slow cure it unless you're in a time frame to get to the next layup?
I prefer the slowest cures I can possibly do. Now again, I don't want to slow cure here because I've got resin against the tool surfaces. If it was a normal production environment and I didn't necessarily need to show you the backside of the part, I would have basically a snap sear resin primer, a primer in the tool, and then I would adjust my cure rate for as long as I can make it. No, sir, I'm not here, but I'll hit the phone number and get you an email or something to you. What's your name, sir? Jeff Rogers? Nice to meet you.
Jeff, how you doing?
Good.
All
right, so...
I didn't know that you got it. I feel terrible until I
If you guys want to look at this one over here, just stay about the post, and you can see that you're looking at the glass up underneath.
It's about time one of them got built.
It's not enough. We're going to actually have a harder time getting the wax off the part than we have getting the wax out of the mold.
Alright, so we can get everybody headed back to the seats, please. So you guys can start working in here.
Everybody head back to your seats.
So this is going to be a canopy, right?
Canopy and secure. If you look at the picture,
So you're doing this entire thing here just to get uniformity in the part. You just cut this out and put a canopy in.
right, there'll be a separately molded copy. There's also going to be an insert into this once the molds are taken to another stage of development that forms all the sills. Just the start. Right.
Alright, so we got everybody to clear off from under those pins where we're working. Everybody back to their seats.
I'm not a fan of
and that particular material is called the denim mat. The denim mat is so handy when putting into contoured parts. And I'll bring some of the cords out. We'll have the cords out. When you bring the cords out, you know, second, in a little while. Any specific questions to anything at this time? So you mind? And it also comes with the PSA or the non-PSA, especially since the I like high-cap pressure sensitive The reason for the last in this application is I want the aircraft was designed with a goggle in the skin. Okay, if the goggle was in the mold, it would act as a lock to the part, so I couldn't get the part out of the mold. Okay, so the wax gives me the proper thickness of that goggle, and it will come out with the part in that hole. Now, at some point in the future, there'll actually be a drop-in goggle too, so you can really use it for what we need in order to use this functionality we have to have the goggle.
You know what you're doing there, girl?
That's right. There's a back part that both skills on loose, much like the laundry line, so it's a constructive component. And then the skins are actually up to each other this way. If you notice in the tool here and over there, those skins on it come out to each other. So the machine is actually that part is and they're designed for self-reproof. So the on the back plate or that angle and that goggle in there allows us to use a 2-inch woven tape to properly fill that in and get me a bond on the other side of it. And in a lot of cases, we'll actually take the core material out from between the two laminates as much as a quarter of an inch and fill that with a structural adhesive between the two. But at that point, I now have 1, 2, 3, 4 bonded within the single part that goes together. So it becomes stronger than the rest of all of them. Are we ready to move on to some
All right. Got a few more minutes here before we wrap up the morning demo. Yeah, we will be back at 2 o'clock. We'll pick up from where we left off with the next layer, or finish up with what we haven't finished here. So you got to hear from quite a few different suppliers. You got a lot of information from us. This will be exactly what you'll see over the next few days at each demo. We're very fortunate to be here. We're happy to be here. It's kind of a one of a kind, especially at this event. You're not going to see somebody making a plane, which is pretty cool. And I'll remind you, we've got an opportunity to name this plane over here. You fill out this form, put it in this box with your name, and we select that name. Then you will receive a desk model of this plane. Maybe we'll even stencil the name on it too. So we also have a registration box for some drawings, for some t-shirts and such, and then we also put you on the mailing list. Remind you as well that all the information from this show will be on the Innegra website, is on these cards. On the back at the bottom, www.innegratech.com. There's a special page for ACI, which is Advanced Composite Infusion demos, which is now Russ's main of Russ's demos. How many years have you been doing this? 6 years. So we hope to continue to be invited back to make planes, and we're flying this one next year here, right? Yeah. So whatever plane you name this right here, it'll be up in the sky.
As a matter of fact, I'll put whoever wins the name of the plane contest, I'll put your name on your plane.
There you go. You put your name on the plane. I need to come up with a good name.
We need a neat name.
You can also fill that form out online on the website if you forget to do it here, or if you think of another name. So
when are we going to close that?
At the end of the show, I'll close the name of the plane.
So you can go online as well. Do we have any other questions right now on any of the any supplier questions, any Russ questions? Now's your chance. You get a lot of information. Russ,
You're actually going to choose the name of the plane?
We are.
Yes, we are.
Yep.
We'll announce who wins. They're going to get a really nice desktop model of the airplane. And I'll put your name on the airplane if your name is selected.
Russ, why don't we talk about the Innegra? There were some questions earlier to Innegra and where you would suggest using it in aircraft and what the benefits are.
Okay. Obviously, the first consideration is going to be the resin system that you select. And if it's going to be in an aircraft, I personally would want to get involved with what you were doing from a technical standpoint, so that I can help guide you through the use of Innegra, so that it actually helps you and achieves what your goals are. I've worked with Innegra and a couple of hundred resin systems, so I've built quite a database on how resins work with Innegra, which ones bond the best, which ones don't bond well, which ones have great elongation, which ones don't. So depending on where you choose to put Innegra within an airframe, I would really want to be part of that decision on where to place it and what resin to use. Having said that, I don't have any hesitations or reservations whatsoever having carbon and Innegra in these airplanes. None. I know from personal experience that by me putting the Innegra on the outside surface of this aircraft, number one, I'm decreasing the carbon load in terms of how much carbon I'm actually putting into it. But more importantly, if I take a bird strike, I know my airplane's not going to break. It is not going to break. It can fracture the carbon, but it's going to stay together and get me home. That's the reason it's there. Later this week, I'll have some coupons that we're going to break for you here at the show, so you'll be able to see exactly. Did you bring those? Yeah. Kind of interesting is if you, this is carbon that's got Innegra on two sides of it. Remember I told you it affected the flexurals, the ductile properties of it. So carbon with Innegra on two sides allows you to twist it, bend it, hit it, pound it, and it will not, it just isn't going to fail. Okay, so obviously you don't want to build your part that way for a wing split, because it's just going to do like that. But let's say you build a part that's going to go somewhere where it is going to be exposed to a lot of harmonics or vibration.
Okay, this is an outstanding way to build a part like that that's going to stay in there and move and not fail. The other thing is that when you use an Negra, it's actually a crack propagation material. So if you do get a fracture in your laminate, this will prevent it from propagating. Now, so you see that how an Negra added to this changes the ductile properties of the carbon. This is the same carbon, but with a Negra on the inside of the carbon. Very stiff. It's acted like a core material for this, okay? Now when we break it, it doesn't fail. Unlike when you watch on TV, you see NASCAR and IndyCar and Formula One cars, and boy, when they hit something, shards just fly everywhere. Not with a Negra. Not with a Negra. So for me, I want a Negra in parts that I know if they fail, I'm still going to get home. Not have the wing fall off and me jump out. So again, when you start looking at how and where to use a Negra, let's talk first on where you want to put it, and then how much a Negra you actually need there, and then let me guide you towards the specific fabrics that would fit that application and that performance parameter the best. Yes, sir.
So, in addition to increasing the tensile strength of carbon, does it also increase the compressive strength? Like in a deep water part that's subject to compressive strength?
Okay, a Negra does not have good compressive strength. Okay, however, you can use a Negra in a compressive impact type application. Okay, so let's say and I do this with impact beams for automobiles, lightweight, super stiff, but understanding composites is really the biggest challenge there is. It's not as simple as what everybody wants to envision it to be. A truly engineered composite part is one where you've taken into consideration every facet of that structure, including the orientation of the fiber, how that fiber is going to work in that orientation, and what is that orientation going to do with respect to transferring loads and energy and harmonics and damage. So if you take a Negra and you put it on unis, okay, and the unis are going to be subject to an impact, all right? We know that we don't have the compressive strength that you really would want in that area, but we also know that we're going to mitigate or we're going to increase the duration of the impact, so we're going to allow it to flex further before failure. Okay? But we understand we have no compressive strength. So if we put it in a 0-90 like this is, it would basically crumple in on itself and lose its ability to actually extend that duration of impact. So on an application like that, we would take the fiber orientation not to a ± 45, but probably to a 30 or a 90, so that I get this material on that impact phase and control its bunching or crumpling by the angle of the fiber. So I extend that out and it allows it to go further without failure. Does that kind of absolutely is.
Subject to compression, like a submersible thing or a water drilling?
It would, yes, and in an application like that, we would be some of the last plies towards the inside. Yes, we would be some of the last plies towards the inside, so that you keep so instead of being in compression, you're in expansion, you're in tension. Okay? The front face is compression, back face is expansion. That's kind of how all of that works. So the other thing too is that the percentage of materials needed to get to the point that your goal is the beauty of composites. You know, I was telling somebody just a few minutes ago that you don't necessarily have to go buy 100% carbon to put into a part A lot of times you don't need all of that carbon to get the extra strength you want. A lot of times folks just don't realize you can buy hybrids. You can buy hybrids that are carbon and glass, carbon and aramid and glass, or any variety of those things. One of the super neat things about Anegra is we offer our fiber in a wide variety of weights and in a variety of commingled materials. So the fibers themselves, we commingle with other fibers. So let's say you need something that's woven that has 8% carbon, 19 or 20% glass, and the rest you want to name. We'll commingle the fiber so it is that. So when they weave it, that fabric is exactly what you need for your structural requirements, your planned and engineered solution for your fabric. Yes, that's co-woven. Yeah. So co-mingling is where they actually mingle the fibers together. Co-woven is where they weave them together. You're going to see two different types of co-wovens here this week. The co-wovens like the texture material. You can hold that one up. And then I have another material that's co-woven that looks more like a typical 2x2 twill fabric. And that'll be over here on this aircraft. And again, it's on the outside of the aircraft, not the inside of the aircraft.
Excuse the question because I came in a little late. I'm familiar with the Starlight design, but who designed this little art?
Jeff Carlo. And did you get to see the pics?
A few of them.
Yeah. It's kind of a fun one, you know. And our little military paint scheme version of it, which is really pretty. And there have been 3 guys who have stepped up that are going to build this one right here with the same little jet engine that is used in the little metal Sonics. Yeah, that'll be very interesting and fun to see.
What's the empty weight of the airplane projected at? What's the empty weight of this airplane projected at?
Under 400 pounds. Under 400 pounds. Single seat. It's a tour. As Jeff calls it, it's a motorcycle for the sky. This is a carbon tube. This carbon tube was actually made in a closed mold, but it used an expanding urethane foam as the pressure implement to create the landing. And this particular type of tube is used in kayaking, and where they're doing that, and they're getting a lot of stress loads on it. And if you break your stick in the backwoods, you know, when you're kayaking and stuff, it's a pain in the butt. Well, this one definitely broke, and the Anegra got them home. You know, and if you feel the part, even though that it's failed, the part is still extraordinarily stiff and rigid. So if you want to feel that and pass it down. Excuse me? Yes, you can do repairs. Now, you know, let's talk a little bit about Anegra and say aramid. Everybody likes to talk about Kevlar. Okay, Kevlar is a brand name of aramid that's owned by 3M. Aramid fibers are made by several different manufacturers. K29, K49, Kevlar distinguish which of those 2 fibers are ballistic grade, rated ballistic grade, and which are not. Tijan Toron is a company that makes a ton of aramid materials in the same grades. That's probably used more prevalently than Kevlar itself. But they did a great job of branding. How many of you have actually used Kevlar aramids? How many of you like cutting it? How many of you like repairing it? It is horrible. it's horrible, but there are uses and applications where you absolutely have to have it. You know, I have fought with the material for so many years and so many applications. I've learned I cut the part whatever size it needs to be while it's a dry fabric, and I bury it in a wet laminate, and I don't ever want to see or touch it again. And if I do happen to cut it, who likes cleaning that cut edge up? It's almost impossible to get rid of all of the fuzzy. You take a razor knife and you just lightly trim it all off to try to get it cleaned up. A lot of the same properties you get out of AirVenture, you're going to get from the Omega. We don't have the same tenacity, but in terms of what non-ballistic type applications require, a Negra fits those bills perfectly. Since it's an olefin-based fiber, not only is it soft and supple and it lays nice, it's not itchy, it doesn't cause any type of irritations. It's easy to cut with scissors, and if you cut it after it's done, you simply take a hot knife or a soldering iron or anything that you can heat and dress the edge with the heat, and it smooths it out just like you would. It polishes it off. So cleaning it up, using it, cutting it, laminating with it is super simple, and it's a drop-in fabric to anything else that you've ever used. Okay.
So what's the melting point?
Melting point on this is going to push 400.
Push or B?
It's gonna dump at 402. So, you know, that is one of the limitations of a Negra is the processing temperature. However, most guys aren't using that high a temperature with their processing.
Jeff mentioned that he's going to see peak exo at what?
He said that the peak exotherm of the system in the 100 gram mass buck can reach 390. In the mass that we have here, we don't have the mass, we'll never see the heat, so there will be no negative impact of the fiber.
Is this something that should be heat cured? Are you talking about something?
Okay, autoclaves and ovens are two different processes. One is heat, one's heat and pressure. Okay. An oven can do anything with respect to cooking that an autoclave can do. Some resin systems are selected for their physical properties based on where you post-cure them to. So when you design a composite part and understand how it has to perform, you select your resin and your fibers and your percentages of both and your processing to arrive at your end result. For example, this aircraft will have an ambient cured fuselage. Wing skins, vertical skins, horizontals, everything will be ambient cured. However, all of the spars will be very high temp oven cured parts with a very different resin system, because they will carry the burden of the load of the work of the aircraft. So it's a
Your product, are you just the material, or do you sell a resin product?
No, sir. Well, I don't sell anything.
Oh, I'm sorry. Not just, or what you're discussing, the material you're discussing.
We are the fiber manufacturer for it. We make the Negra fiber.
Yeah.
We sell the Negra fiber to other weavers or to pultruders or to winders, filament winders, people like that. They weave it into the products that clients request.
So, as far as it having it available in a pre-preg, is that something?
It is available in pre-pregs. Yes.
Who can you buy it from?
Jen can address that for you.
So are you specifically looking for the Negra pre-preg or any of the product pre-preg?
We're well, I'll tell you what. This is a little bit off subject. We're interested generally for the forum.
Okay.
Very interested in that. We're doing a little bit of fiberglass work. We're just interested in your process for finishing and ambient temperature finishing.
Okay.
But this is very interesting. Now, will this bond with a regular fiberglass also? We have a regular fiberglass. It's an RV10 shell.
Okay, and there's going to be a lot of finish work. I imagine there's going to be some thin fiberglass layers. Does this bond okay with regular fiberglass and say a West System epoxy?
Are you talking about the Negra or the resin they're using? The Negra.
Yeah.
The Negra actually bonds best to the glass, and that's one of the reasons that they're using glass first, is to encapsulate that resin with the Negra fabric. So glass is our friend, definitely.
Do you like West System epoxy?
That would be a Russ question.
What type of resin do you like best? We have been using West System, very typical for everybody, I'm sure.
There's not one that I like over another. There's some that I use more than others. I believe in supporting those that support you, sort of thing. This particular resin system that we're going to use here is an outstanding resin system. It's manufactured by Endurance Epoxies. It is, by the way, used in some aviation parts. I can't say whose they are. I can't tell you what they're in. But Endurance Epoxy, yes. Epoxy Cal is another name. They don't have a booth here. They will have a representative here a little later in the week, but they're not here now. But they do a wide variety of resin systems, anything from basically laminating epoxy resins to infusion resin systems to super high temperature resin systems. You guys, some of you in here maybe have used crystal resin before, where the resin's actually crystallized, hard crystallized, and you elevate the temperature of it very high to cause it to go to viscous and you can use it. I mean, depends on what you're trying to achieve.
Yeah, we're more interested in the ambient temperature cooler.
What are you building?
It's an RV10, which is a fiberglass metal frame.
Got it.
So we're looking to do the finish work that connects the metal to the fiberglass.
Okay.
A lot of guys are using the fiberglass or West System epoxy, one of the other epoxies, and microballoons, that's fairing compound to fair everything in. So I was just looking for some options as far as epoxies, and I also like to use a little bit of glass. And a lot of guys will just put it in bare with no glass. I like to use a little bit of glass just sort of hold the whole thing together, gives it a little more durability. So, and I was also going to ask you what weights. I just might have walked in a little bit late. What weights your fabric comes in?
On the Negra fabrics, yeah, we've got a couple minutes, and we will be back at 2 o'clock. I'll answer your question. Please fill out the information up here. Name the plane. We also have some brochures and information. We have our schedule on the palm card, so please come back and see us. We're here all week. As far as the fabrics, the Negra fabrics, they are available from less than an ounce in a scrim type material up to 20 some ounces. Of course, heavier can be made as well. What is on the market now are fabrics that have gone into the applications that are using the Negra. So they weave extra, they keep it in stock. So there are anything from 100% of Negra. Most common is a 3.5, 4 ounce, or anywhere from 2 to 4 ounces on the 100% of Negra. There are also some in the 15 ounce, also in the 20 ounce. And then you're looking at basalt Negra, carbon Negra, glass Negra. All of those are on the market. He mentioned the Negra itself, and then also the hybridized. I don't know if you're here yet. The commingled. There's some commingled fabrics as well, where we take the Negra yarn and high malodorous yarn, commingle them together, and then weave that. So there are a plethora of fabrics. I would say upwards of probably close to 50 different fabrics that are available globally as far as the Negra. As far as pre-preg, Axiom has done the most. Cytec has done some. Tenkata is doing a little bit now. So we're looking to expand pre-preg here in North America, over in Europe. SHD is doing some, and also Elmira, and Elmira does both here and in Europe. And then in Asia, SK Chemical does a lot. Tang Yang's working on it as well. So as we look at getting into other markets and the interest in the Negra grows, you'll certainly see more options available too.